All right, guys, welcome to AB 122. This is AB Electrification and Control Systems. I'll be the instructor for both the lecture and laboratory classes of this subject or this course. We'll start with the syllabus of the course before we proceed directly with the discussions. The manner of or the mode of delivery for the class would be via recorded lecture videos and live laboratory or synchronous laboratory classes, online classes. Okay. Let's proceed with the syllabus. All right, so we start off with the philosophy, vision, mission, and goals of the university, collectively referred to as the PVMGO. Now, our philosophy as a state university of the Philippines is it's education for sustainable human development. Now, the vision of the university is to become an agricultural research university of global standards. And the mission is to lead in innovations and to build resilient and sustainable communities. Quality policy. We have the university committed to lead innovations in instruction, research, extension, and resource generation. These are the fourfold or the four-tier function of the university: instruction, research, extension, and resource generation. For the satisfaction of its clients, that would include you students, uphold its core values and principles, and satisfy all applicable requirements and standards through continual improvement of its quality management system. Okay, our goals as a university: enable transformative and inclusive learning experiences, generate new knowledge and technologies, engage and empower communities, intensify internationalization and resource generation initiatives, establish a one e-governance system, and enhance management of university resources. The guiding values of the university: quality and excellence, professionalism, teamwork and unity, liberalism, and institutional pride. Our core principles: discipline, respect, and care. Now, our university goals. Okay, we have our college goals, the College of Engineering and Food Science, anchored on this university goals. That's why, if you could see this table, okay, the college goals are cross-referenced to the university goals, meaning the college goals, the individual or the individual college goals are targeting this specific university goals. So we have development of students' lifelong ability and skills to make them work, life, and world ready. That's accomplishing university goals 1, 2, 3, and 4. We have your experiences in the classroom, generating knowledge and technologies through research. Okay, engage and empower communities, and that would be your world ready function. And then you have your last year, your internationalization and resource generation. Number two college goal is to upgrade continuously the quality of the ABE and FST programs. Okay, university goals 1 to 6, except 5. Now, college goals 3, 4, 5 are anchored on the university goals 1 to 6. The college goals are enhanced qualification of faculty members and staff, modernize infrastructure facilities and equipment for instruction, research, extension, production, and entrepreneurial development. Develop, implement, and deliver cutting-edge, gender-equal, environment-friendly research, extension, production, and entrepreneurial programs. Now we proceed with the program educational objectives. The program refers to the to our uh, the BSEBE program. Okay, so after 3 to 5 years, the graduates of the BSEBE program shall provide leadership in planning, implementation, and monitoring of ABE projects and programs, occupy supervisory positions in private and public organizations locally and internationally, own and or manage ABE-based business enterprises, pursue advanced studies in ABE in emerging fields, occupy responsible positions in ABE education, and lastly, support and value the preservation and protection of natural environment, gender, and development advocacies. These are now anchored on your college goals. For the student outcomes, these are the program outcomes. By the time of graduation, the students of the BSABE program shall be able to apply knowledge of mathematics and science to solve complex ABE engineering problems. Understand sorry. You have number 2, letter B, design and conduct experiments as well as to analyze and interpret data. Design a system, component, or process to meet desired needs with realistic constraints in accordance with the standards, as those are anchored on PEO, or the program educational objectives 1 to 6. Letter D, function in multidisciplinary and multicultural teams. Letter E, identify, formulate, and solve complex engineering problems. F, understand professional and ethical responsibility. G, communicate effectively complex AB engineering activities with the engineering community and with society at large. H is understand the impact of AB engineering solutions in a global, economic, environmental, and societal contexts. I is to recognize the need for and engage in lifelong learning. J, know contemporary issues. K, use techniques, skills, and modern engineering tools necessary for AB engineering practice. L, know and understand engineering and management principles as a member and leader of a team to manage projects in multidisciplinary environment, And M, understand at least one specialist field of ABE practice. Okay, so those are for you, or for your overall stay in the university as a student of the BSABE program. And the course, this specifically AB Electrification Control Systems, or AB 122, okay, which is review of basic electrical engineering concepts and design of residential and farms and wiring systems. It's anchored on this student outcomes. Okay, or program outcomes. So if you could see your the outcomes of the course, or what you are expected to get or absorb or learn, okay, they are anchored on your program outcomes, specifically in the sense of demonstration, because this course is a demonstrative course, so you should be able to experience by demonstration. So we have the concepts of the DC, the direct current and alternating current. You have your demonstration of proper electrical measurement and wiring installations, explore and understand power generation and transmission, and develop mastery of power distribution at the farm level, design residential electrical systems, and lastly, design farmstead distribution systems. All right, so we're not done with the PBMGO, and we will now be proceeding to the course proper. The laboratory exercise report formatting guidance shall be discussed in the lab. And well, we proceed now to your first topic, which is just a review of your basic electrical engineering concepts, from the DC to the AC to inductance and capacitance, RLC, and then well, we have the electrical energy basically to transfer energy, or yeah, to transfer energy so that power can be used in a specific location away from where the source of power is, or source of energy is. So we now talk about apparent power, reactive power, and real power. And then lastly, since these are systems, okay, we have mechanical and this is electromechanical systems. So we talk about efficiencies, and now we have, in sense of the electrical concepts, the power factor, and to improve it, we have the topic of power factor correction. So you have assessment tasks, and you have a pre-test, and then exercises and laboratory exercises, and then, well, the very basic discussion board to discuss whatever it is that you want to discuss beyond the or within the topic, but not covered. Okay. So that's going to be weeks 1 to 2, and then we have weeks 3 to 4. We talk about the generation of electrical power, the concepts of energy generation. Again, the power sector is divided into 3 domains: the generation, transmission, and the distribution. So generation, we'll talk about power generation. Okay. Usually this is far from where the energy is if we're talking about grid tied electricity. So we talk about conventional, okay, generators. Okay, what are these? We have a lot. Okay, we have a lot of conventional energy sources. And then next we talk about renewable energy: hydro, solar, wind. And then last is the biomass type. We have the biofuels, biogas, and the new renewable fuels. Hopefully, we'll be able to size and design a solar photovoltaic or the PV system. Okay, this is, but the objective of this is for you to support or establish an off-grid system. Okay, when you say off-grid, it's cut from the main grid. Okay, so the main grid is a very large. We'll talk about that, but it's for the benefit of this just this introductory portion. Is we have the grid as a very big system of branches of distribution networks for electricity. Okay, so week 5. Okay, before we go to the first assessment practice exercise, and that's going to be power transmission and distribution. So we just connect with the topic on the generation, and we talk about power grid extension, okay, transformers, service systems, okay, what is available. We have the single and three-phase, and we talk about electrical grounding, how it's very important, specifically that the Philippines, okay, we have problems about this in our country. So we have week 7 to 8, wiring of agricultural and biosystem structures. We talk about electrical safety, okay, wiring. We familiarize with the standards, okay, and size, wire, and installation, okay, necessary for the distribution of current in a specific purpose, okay, specific application. So we are, as engineers, okay, as future engineers, you are expected to be able to safely manage and also design the wire sizes, because we would not want an over-designed electrical system or circuit in a building or a farmstead. Okay. Next is lighting system. So we have light sources, lighting requirements, methods of computing the illumination. We have lighting system design, computation, and we talk about the fixtures that's available for use, and the lighting loads, and how to determine them in a specific AB structure. And we now compete for the lighting system design. If you've had your structural AB structures engineering, there's a requirement for specific eras in a certain farm structure, EV structure, such as, for example, in the barn. Certain activities, such as those that require tedious or eye involvement. So you would need a lot of light in there. Thus, the requirement for high or very in high intensity illumination. Okay. Next, this is topic 6. We have electrical controls, and there are 3 types: manually, automatically, and commonly used sensing elements. And hopefully, we'll be able to tackle the very common the microcontroller. Okay, from the manually operated controls available in previous iterations of the car, and most mechanical modes of transport, such as trains and even submarines. So the manual controls were eventually automated, and then via the the IT revolution, the fourth industrial revolution is actually ongoing. We have the introduction of computers in this electromechanical systems. So we talk about also sensors. Okay, what are the commonly used sensing elements out there? Week 11 or topic 7, we talk about the motor, which is the prime mover in farms, and we talk about its different applications. We have the different types as well, and characteristics, the selection of motors, and the sizing of conductor for motors. Okay, week 12, we talk about, we have the practice exercise, the second one. Okay, and week 13 to 14, we have this residential electrical distribution system, the kinds of outlets, the branch circuit, and the sizing of the service entrance. Okay, we tap the electricity of the farmstead or an AB structure from the service entrance. Okay, this is made available to the farm or the agricultural land via the distribution supply of the location. So it could be from a transformer, or the farmstead could have its own transformer. Okay, depending on the use, particularly if there is a need for a 3-phase system and it's already far from a certain location, from the main, from the transformer that's servicing that area. Okay, so we know the branch circuit and the main panel board. Okay, and we talk about the different commercial available electrical outlets. Okay, weeks 15 to 16 covers farmstead electrical distribution system. We talk about the wiring, the demand load, and the concept of central metering and distribution, and the capacity of the main service for farmstead, and selecting service conductors. Last topic is selecting is connected to your wiring. So an initial knowledge of the wiring system is very much required. And last topic is the standby farm power, where we talk about the different generator types and sizing of a standby manually operated generator. What's the size that's required? This is based on your demand load for your structure or your farmstead. And then we talk about batteries and power storage. Okay. Hopefully we talk about here the pump hydro, or just the dam storage. Okay, because that is a battery, a water power storage battery. And then we have the last exercise, the assessment period, practice exercise, and the project, which is a farmstead electrical distribution system design. The exercises will be discussed much in detail in the lab. We have first the DC and RLC circuit analysis, electrical measurements and power factor correction, solar electric system design, wire size and outlet system design calculation, electric motors and electrical controls, lighting load calculation, the lighting system design, farmstead electrical system design. Okay, distribution of the topics. very much easy to uh, to go through, okay, to understand. And we have the textbooks by Gustafson and Morgan, Fundamentals of Electricity for Agriculture by the American Society of Agricultural and Biological Engineers, ASABE. We have Survey and Jewett, okay, Physics for Scientists and Engineers with Modern Physics. We have other books. Okay, this is a biographical book, and then the electric motor handbook and electric motors and drives by use and Duray. Okay, some references as well, and requirements are okay. You have your diagramming software such as Visio or Microsoft Visio or Design Spark Electrical, and your CAD software. All right, so I think that will be all. We go directly to the next topic in the next video, which are recorded, okay, for everyone to watch via hopefully a streaming free streaming service. Okay, I'll update the class by the VLP and the Google Classroom. Thank you for listening. Again, this is Ian for ABE 122.